welcome back to another edition of Easy Theory. So let's do an example of the merge sort algorithm. So at a high level, remember, we have a list, we want to sort it, and the idea is to use recursion to assume that we split the list up into two pieces that are both sorted, and then we take these two sorted pieces and put them together using this merge function down here. And we saw how to do that before. So the good thing about that is that the two individual lists are sorted, and then we can just merge them together really easily. So let's actually just make a list. You can assume that the list of the size is a power of 2 for the purposes of runtime. So let's just pick a list with 8 elements in it. So I'm just going to make this completely at random. So 5, 2, 4, 7, 13, 1, 8, and 9. Okay, so this is just a list that has 8 elements in it. It's obviously not sorted. Let's sort it in ascending order in this case. Okay, so what does the algorithm say to do? Well, the algorithm says to look at the number of elements in the list, which is 8 now. If n is at least 2, obviously it is, then we call merge sort on the first half of the list. So now we're in the first recursive case. And what I'm going to do to help visualize this is to show what the first recursive call actually is, which is going to be on this first list right here. So actually I'm going to do it this way. So the first recursive call is going to give us a list with 5, 2, 4, and 7 in it. And then so now we just called the merge sort function, the whole original function with this list. It's not creating a new list, but this is the list we're actually looking at that's within our list. So it's not actually allocating a new list or anything, but it's just that the bounds of the list that we're looking at is the first half. Okay, so now we look at the number of elements in this list, which is obviously 4, and 4 is at least 2. So again, we're going to recursively work on the first half of this now smaller list. And I'm going to do this in green. So the first half of this list is 5 and 2. Okay, so then now what do? Now we just called merge sort with this list right here, which has 2 elements. And as you might expect, because it has at least 2 elements, we're going to recursively call again with these 2 and split and just look at the first half of this list, which is just 1 element. So we're going to have 5 right here as the 1 element. Okay, so then now we call merge sort with this little list. And now there's only one thing in the list, so this if statement is never checked. It's never gone into, it's false. Which means nothing else is done with that 1 element, because remember, a list with 1 element is automatically sorted. So then now we go back up to this recursive case because the first one is done. The first one is done. So therefore we called the second recursive call because this one was done for this list. So then now we call the recursive function on the second half of the list, which is just the 2 right here. Okay, so then now what do? Well, and we know that since this is 1 element is automatically sorted, nothing is done with this 1 element list. So then now, again, we're going to come back up to the recursion 1 level to this list. So now both recursive call functions are done. So the only thing left is to merge the 2 lists together. So, i.e., we're merging the first and the second half of the list. So here, well, if we look at these 2 elements and try to combine them into 1 list, then we notice that by merging, the 2 is the smaller one compared to the 5. So the list that we're going to get here is 2 and 5. Okay, which is obviously sorted now, which is good. Okay, so then now so this recursive case is completely done. So then we come back up to here, and then we see that the first recursive case is done. So now we do the second recursive case, which is going to look at the second half of the list, which is 4 and 7. And then again, break it up into two smaller lists, 4 and 7. And each of those is individually sorted. So then now we're going to do the combine operation with the two. And we can see that the 4 is smaller than the 7. So the list we're going to get is actually exactly the same as what it had before, which happens. So merge sort doesn't actually look at the elements and make a prediction, make a choice about what to actually do other than in the merge function. So about how the splitting is done, it doesn't care what the elements are, which is really nice. Okay, so then now these two so for this, so for this one, all recursion is done, so this part is completely done. So then now for this one, because we go back up a level, the recursion's done. Both recursive calls are completely done. So then now all we have to do is to merge the two halves. Well, what are the two halves? They are these two halves right here. So I'm going to try to merge them. So this one's a little bit more complicated because it's got more elements, but the principle is exactly the same. We look at the first elements of both lists, and then we insert the one that is the smaller of the two, which happens to be 2 in this case. So then the 2 is not chosen anymore. So then we look at 4 and the next one in this list, which is 5. So then 4 is inserted. Then we look at 5 and 7. 5 is smaller. And then we insert 7 because it's the only other element left. Okay, so that's the first half of the whole list. So now the first half of the whole list is done. So then now we need to do recursion on the second half of the list. So now we gotta look at that, which is 13, 1, 8, and 9. The reason I chose a power of 2 is so that we never had to do any flooring of when we divide by 2 in the length. So that's the reason why I did that. Okay, so for this one, again, we got to break it up into two smaller lists. So 13 and 1 for this one, 8 and 9 for this one. Okay, so then this first one, again, gets broken up into two smaller lists of size, in this case, 1. And this one gets broken up into two smaller lists, which are 8 and 9. And then now, of course, we're going to have to merge these two. So if we merge these two and have them be sorted, then the result is going to be the list which has a 1 and 13 in it. And if we merge these two, we're going to get 8 and 9. For correctness, I should go through the recursion exactly every single time, but we know what's going to happen here because I did the first example. So then now we merge these two lists. So we look at the first element of each, 1 and 8. Well, the 1 is the smaller one, so that one comes first. Then we look at 13 because it's the next one, and 8 because that's the one I still have yet to put in. Well, that's going to be 8. Then look at 13 and 9, and then it's obvious that it's going to be 9 and 13. Okay, so then now we have done the complete recursion on the second half of the list. Now all we have to do is just to merge the two halves together. And so these are the two halves. So let's actually try to merge them. Again, this is more complicated because we got more elements, but I'm sure we can do it. So again, we look at the first element of both lists and put in the smaller one, which is this 1 in this case. So 1 goes in. Then we look at the 8 because it's the next one, and the 2 because I haven't put it in yet. And so therefore the 2 goes in. Then we look at 4 because it's the next one, and 8 because I have not put it in yet. The 4 goes in, obviously. Then we look at 5 because it's the next one, and 8 because I haven't put it in. Then 5 goes in. And then similarly, 7 goes in because it's less than 8. And crucial thing to note, the first list is completely exhausted, so therefore we can just put in everything else from the second list because we know that it is sorted. So in goes 8, 9, and 13. Now I don't know about you, but that looks like a sorted list to me, which is pretty nice. So the whole idea is to use recursion to assume that the two pieces are automatically sorted, and assuming that, then all we need to do is to solve the original problem, which is to have the whole list sorted. So that merge function is the crucial one, to be able to take the two halves and put them together. As long as the original two lists are actually sorted, we can do that really easily just by comparing the first element of each list and then moving the elements we're looking at as we're going along. Okay, so that's an example of how merge sort actually works. If you have other interesting examples, put them into the comments below. As always, please like and subscribe to the channel. It really helps us out. And as always, I'll see you next time.